Good morning, good morning, good morning. I hope everyone is happy and healthy and doing well. So, let's get down to it. Starting on 6-1, we are talking about exponents. This one is nth roots and rational exponents. Okay, so when we take the square root, we're thinking, hey, what number multiplied by itself 2 times gives us a number under the radical? If we take a cube root, we're thinking, okay, what number to the 3rd power? So it's super important for this particular assignment that you have written down some common roots. So if you don't already have this written down somewhere, please do so. Common roots. So let's first do just square roots. So if you don't have these memorized, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. Now 121 is 11. 144 is 12. Now, it's interesting for 13 and 14. They're the same terms. Both of them, you got to keep in mind, they're both start with 100. So 13 is 169 and 14 is 196. So you can see the numbers are just flip-flopped around. It's the way I remember them. 225 is 15. 256 is 16. And then some bigger ones would be 900, 400. So if you look just at the first number, you can say that it's 2. And then because there are 2 zeros, you're just going to add the 0, so that's 20. 9 is 3, and you get rid of one of the zeros. So that works for all of them. So like if we take 1,221, with 2 zeros, we know that this is 11 with 1 0 afterwards. All right, so that is square roots, but what about cube roots? So there are some cube roots that you should kind of keep in mind. So the cube root of 8 is 2, because that's 2 times 2, which is 4, times 2 is 8. So 3 times 3 times 3, 3 times 3 is 9, 9 times 3. So the cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125 is 5. Those are predominantly the cube roots. And then 4th roots, so 2 times 2 is 4, and 4 times 4 is 16. So the 4th root of 16 is 2. And if we think about this the same way, 3 times 3 is 9, and 9 times 9 is 81. So the 4th root of 81 is 3. So I want to make sure that you guys have all of these kind of memorized in your notes, kind of important to kind of have in your wheelhouse. Okay, let's go back to this, sorry. So the square root of 16. So what times what is 16? 4 times 4 is 16. What times itself 3 times is 8? Well, you can see from our list down below that this is 2. And the fourth root of 81, again, I told you this is important, that would be 3. I didn't do any fifth roots. Okay, and we've got a negative in here. So when we put negatives on the inside, the only time we're going to be able to find a real root, is if the exponent is odd. Why is that? Well, if we have a negative 3 times a negative 3, it's always going to be a positive. So if you're multiplying two negative numbers together, it's always going to end up positive. So you have to keep in mind that the only way to get a negative number on the inside is if it's an odd root. So we're going to have it as negative. And then 2 times 2 is 4. 4 times 4 is 16, times 2 is 32. So it is negative 2. Now, we can also write them as exponents in different ways. So there are a couple different locations. Okay, when we're looking at a fraction, I want you to think of the top number, the numerator, becomes the exponent, and the denominator becomes the radical. So what does that mean? If I have x to the 1/3, that means the 1 becomes the exponent, and the 3 goes out here for the radical. So when we're looking at fractions, we're thinking of the top number is the exponent, the bottom number is the radical. So here we have a 1 as our exponent. So what is our exponent? Well, our base is x. The exponent is 1. The radical is 3. So that's x to the 1/3. The base here is y. The exponent is 5, so it goes on top. The radical is 6. The base in this last one is 3x. And so I'm going to put that in parentheses because it applies to both the 3 and the x are inside. And 3 is the exponent. Radical, because it's square root, it's actually a 2. There's a hidden number 2 hanging out there. Okay. To put it in radical form. So again, remember we think the numerator is the exponent. The denominator is the radical. So we're going to write it in radical form. Z goes inside, it's our base. 1 is our exponent. 5 is our radical. 6x goes inside. 3 is our exponent. 4 is our radical. Now I can either put the 3 here, or I can rewrite this as this way, with the 3 on the inside. Both of them are correct. So here I've got 8 is my base, 5 is my exponent, 3 is my radical. Now, when it says evaluate, you need to actually find the value of it. So how are you going to do that? Well, let's first rewrite it as a radical. So 16 is my base, 5 is my exponent, 2 is my radical. Do I know the square root of 16? Yes, that is equal to 4. So it is 4 to the 5th power. Well, I can then find that, which is 4 times 4 times 4 times 4 times 4. So this is 16 times 16 is 256 times 4. Or let's just use a calculator. So calculator, 16 times 16 times 4 is 1024. Okay. I always put my negative in the numerator. And I'll explain that in a minute. So, I'm going to rewrite this as 64 to the negative 2 over 3. So, what is our base? Our base is 64. And we square that to the negative 2 power. And then the cube root. So I can look down at my list. Do I know the cube root of 64? Oh, yes, I do. The cube root of 64 is 4. So I have 4 to the negative 2 squared. So 4 squared is 16 to the negative 1. So how do I deal with this negative 1? Well, that simply means it is going to be 1 over 16. So our final answer is 1/16. Okay, so what about this? Well, here we've got a problem that's an equation. So the easiest way to do this is first add 5 to both sides. So we have x to the 3 halves is equal to 5/12. Now, if I'm going to do something to one side, I'm going to do it to the other. So to get rid of this exponent, rather than dividing or whatever, I can't do that. I'm going to multiply everything times 2 over 3. So I'm going to take everything to the 2 over 3 power. Now, why am I doing that? Well, because then the 3's cancel with the 3's and the 2's cancel with the 2's. And what do I have left on this side is simply my x. So my x is going to be equal to 5/12 to the 2/3. Now, how do I deal with that? Well, remember, 2 is my exponent, 3 is my radical. So my base is 5/12. I'm going to do the cube root of 5/12 squared. How do I do that? Well, let's see. Cube root 5/12. Okay, so this is 125. So let's think about this. 6 times 6 times 6. Well, 6 times 6 times 6. That's 36 times 6. 6 times 6 is 36, carry a 3. That is 18 to 16. Okay, not quite there. So 49 times 7. That's 63, carry a 6. 28. 34. Okay, not there yet. 64 times 8. That's 32. Carry a 3. 512. Yay! So the cube root of 512 we just determined was 8. And 8 squared is 64. So x is equal to 64. So how do I get rid of my exponent first? I'm going to multiply it by 3 over 4. I'm going to raise it to the 3 over the 4 power. That gives me x minus 7 is equal to 81 to the 3 over the 4. As a reminder, the numerator becomes the exponent, the denominator becomes the radical. So we have x minus 7 is equal to the 4th root of 81 cubed. Well, the 4th root of 81 is 3. So we have x minus 7 is equal to 3 cubed. And I know that 3 cubed is equal to 27. So x minus 7 is equal to 27, and the opposite of minus 7 is plus 7. So x is equal to 34. All right, so using this, you should be able to complete the assignments, and I will talk